Dignitaries on the dais, ladies and gentlemen, I am ML Sachdeva, former Chief Engineer, Central Electricity Authority, and retired in 1996. After that, up to 2015, I rendered consultancy in India as well as in other countries. Now, I am presently from 2015 I in USA. Before I start on the subject, before I start on the subject, I would like to give some information as a background, which was in 70s, a similar conference was conducted in CPRI with the IIT Roorkee, and CPRI presented a paper on the pumping of water from the canals to the irrigation for irrigation to the fields. Then in 1987, and also demonstration was given in the Nangal Canal, near to the Nangal Canal, the river flowing through the Ropar in Punjab. In 1982-87, I was in Bhutan, and I saw that the Royal Government of Bhutan Power Department were having small turbines with generator equivalent to size of the post box, and they were putting on the creeks through which water was flowing and making a small weir, collect the water and use this dynamic property, and then generate a few kilowatts for the residents, which were small few number of residents due to isolated areas. Now coming back to the paper itself, I would like to discuss that hydrokinetic turbines uses kinetic energy of flowing water in the river, terrace, etc. irrigation canals with natural potential head for generation of electric energy or pumping water for irrigation. The HKS differs from conventional hydro generating station, which utilize potential energy of water through construction of infrastructure, storage dams, small diversion dams on run of the river, and barrages. The ocean energy includes tidal and wave energy and ocean thermal energy. Ocean current represent another potential energy source in which the flow is unidirectional, contrary to bidirectional tidal variation. Hydrobeing of CEA took up development tidal generating project long time back, but with no success. This table shows the major tidal power plants in the world which are in operation. In the South Korea, the capacity is 254 megawatt. In France, it is 240 megawatt. In Canada, it's 20 megawatt. In China, it's 3.9 megawatt. And Russia is 1.7 megawatt. There are many other cases, and now UK is trying to be the biggest tidal station for the power in their islands. The type of HKTs are generally based on the flow to water flow to the wheels or to the this turbines blades. No type of flow can be axial and or cross, but mostly axial flow with some variants are used. A on the figure on the right, A shows the axial flow and B shows the cross flow. Then type of foundations, one is it is bottom structure mounted, which is on the left of the figure, and then is the near surface mounted, which is on the right of and fully surface mounted, which is on the extreme right of this thing. Then there's a pivot arm. This figure shows pivot arm method of supporting the water wheels at HKTS, and the pivot arm is pivoted at the rock or soil, and the turbine is hung into the river water. Details of categorization HTS. Hydrokinetic turbines are categorized as axial flow, cross flow. Axial flow is horizontal axis and inclined axis. Horizontal axis is further subdivided into solder mooring, buoyant mooring. Buoyant mooring is again divided as non-submerged generator, submerged generator. Then other type, which is a inclined plane. Then in case of cross flow, it is in plane axis, and the second one is a vertical axis. Vertical axis is further divided into 5, which can be seen from the figure on the right side. Standards ruling the kinetic HKTS. There are 5 IEC, and these one of the IEC 626004-4 2020 also, in addition to requirements of the specific requirement of the HKTS, also indicate the status of its present situation. So the categorization is given in from 1 to 9. 1 indicates the basic principle observation, and 8 indicates system complete and qualified, and 9 indicates actual system proven in the operation environment. This figure shows the testing of HKTS. This is experimental setup in IIT Dhanbad. The reference is from the conference which has been conducted by IIT International Conference in 2019. On the left, you see of the figure gates to control water depth in volumes. So by changing the quantity of water, you can change the speed, you can change the power of the HKTS and check the rating. Development of surface hydrogen turbine technology in India. CA issued a publication in October 22, which recognized indigenously developed surface hydrokinetic turbines technology under hydro category. Then manufacturers of SHKTS. There are 2 manufacturers of SHKTS in India. One is Messrs. Macleck Technical Project Laboratory, New Delhi. They are developed there on their own without anybody guidance or partnership. They claim their turbines of rating TRL9. Second is Messrs. IMP Power, Mumbai, which is a in co-partnership with Messrs. Smart Hydropower, Germany. Its achievement is TRL8, based for installation in India. Installation in India is Chila Power Channel, axial flow 25 kW, Dehradun, Uttarakhand. Niveli Institute Corporation, Chennai, TN, axial flow 4 into 5 kW, supplier IMP, and Kakad HEP, axial flow 5 into 5 kW in the tier race of 50 megawatt HE project, Kerala. For more details, refer CA and publication. It is also proposed that since this has been, HKTS has been considered as a renewable source of energy, the Government of India, CA and REC shall ensure and encourage adoption of SHPG in the country as incentive for farmers, incentives for unserved community, similar to that adopted for roof type due to large network of natural rivers, irrigation, rivers, small trees, etc. This figure shows on the left the section of 5 kilowatt Niveli HKT unit supplied by IMP Power Limited, and another one shows on the right shows the schematic diagram HKT connected to end user. And you will find there are floors on the left and right to augment the supply of water. Then there's a protective stream from water stream. Then there's a rotor arm which is inside, which rotates with the water, then generator, and then connected to the power system. Installation of HT in foreign countries. Since 2013, more than 300 projects have been developed by 280 different companies. Most of the axial flow turbines are there. Among the biggest company, 194 are in USA based, 45 in UK, 19 in Australia, and 19 in Canada. And in Euro countries, 8 are in Ireland and 5 in Denmark. Some of the manufacturers are Ginnard Energies, Ocean Renewable Power Company, Pradant Power, and Marine Current Turbines. Alaska carried a study for off-grid power from glacier canals under lower frozen, upper layer frozen, and flowing water below. Study in Thana River revealed perennial, uh, perennial renewable energy of 1100 terawatt annually by the lead research University of Alaska of Fairbanks, then Alaska Center for Excellence in Partnership, testing in Tanana River, and pilot project to demonstrate the feasibility of effectiveness of hydrokinetic system in the community. This would avoid pollution due to running of diesel engine for meeting energy requirement. Examples of this HKTH existing systems are the Roost turbine installed in Rosas Canal, USA, 3 meter in diameter and 10.9 kilowatt rating. Then second is Vardhan Power, actual HT, 5 meter in diameter, 35 kilowatt of power and power coefficient between 0.38 and 0.44. The installed 6 HT generates 70 megawatt hours of electricity at East River, New York. Then third one is Seagun Axial HT, 18-meter diameter, installed in Stankford, Ireland, with rated power of 1.2 megawatt and producing 6,000 megawatt hour per year of the electricity. Hydrokinetic turbines can also be used to operate off-grid irrigation pumps like the Axial HT in Navia, Colombia. That is 1 meter in diameter and 1 kilowatt per se. This shows some of the figures of the turbines, which the top one is of G Kinetic Energy Ireland. On the left down is the Ocean Renewable Power Company, Canada, and the extreme right, the small hydrokinetic turbine in USA. Then on the left and under this, there is a simple spiral pump, which is equivalent to a water wheel pump and which used as a random turbine for emission-free pump water without electricity and a viable option for pumping water, especially in rural areas and developing countries. Simple electricity and low maintenance costs make this spiral pump a favorable environmentally friendly and alternative. Energy calculation in SHET method. There are two methods. One is FCEA and another one is German-Thornton turbine. The basic formula of the energy is same in both the cases, which is P theoretical half rho A V cube, where rho is the density of water, A is the swept area of rotor, and V is the flow velocity. Cp is the power coefficient, which will convert the kinetic energy into the power captured. The Cp is worked out, can be taken out from the curves given below, which is on the left side for the HKTS and right side is for the windmill. German Thornton turbine. Kinetic energy, flux, and Bob's same formula, where P is water density, which is 1000 kg per meter cube, A is flow area intercepted by turbine, and B is free stream velocity, which is taken as a 0.5 meter second, which is very small, little kinetic energy. Power density, when calculated by putting 1 meter area, you get 62.5 meter watt meter square. Full mass would intercept 62.5 into 2.55 is equal to 159 watt of kinetic energy. For 1.8 meter diameter shaft area 2.5 meter square and turbine generator combined efficiency of 30%. Like in the previous case, CA curves are there. Here the assumption is made as 30%. Power delivered is equal to 47.7. This is the bottom end of the Compton range, and it is claimed that up to 2 kilowatt can be generated at higher velocities. Carry home. India renewable energy goals and global push for the net zero mission, the adoption of eco-friendly surface-connected SHC and economically viable energy generation technology. CA issued publication in October 21 in recognition of SHKT for India extensive network of water bodies, including canals, rivers, and hydropower terrace channels. Energy calculation proposed by third SKT is listed as per CA, an example of German turbine. Hydrokinetic turbines, mostly axial flow, are already adopted in different countries: USA, UK, Australia, Canada, Ireland, Denmark, and some in India. GOI, CA, REC shall explore adoption of SATs for uncertainty to farmers incentives similar to the adopted for roof type solar. Thank you very much for patience hearing. Here is the reference list.